Hey guys, so today we are going to learn about some basic mathematical concepts to be used in chemistry for problem solving. The first is logarithms. Many people actually don't try to learn logarithm because they think it is a very tedious process. So it's not. Dividing or multiplying by four numbers, like a 4-digit number multiplied to 4-digit number, again to a 4-digit number divided by a 4-digit number, very hectic calculations, right? So we are going to reduce those to simple addition and subtractions. Okay, so multiplication is reduced to addition, division gets reduced to subtraction. Got it? But it's not like that. It's a function, right? So we have to learn about some basic concepts. First, suppose a into b, two numbers are getting multiplied. So log of a into b is actually equals to log a plus log b. If I am writing a divide by b, then log a by b equals to log a minus log b. So whatever comes in the numerator is written in the positive side, and whatever comes in the denominator is written with a negative sign. Okay. The third thing is, if suppose we have a to the power b, log a to the power b will be equals to b times log a. Okay, so we can prove this actually. So we can write log a into a into a into b times now it will get reduced to log a plus log a using the first property plus log a plus b times. Okay, so this is actually equals to b times log a. Okay, now suppose I'm trying to write, will actually understand how to convert a problem into a logarithm and how to convert back into the problem again. Okay, suppose I have a question. You have been asked to calculate 1 2 3 4 into 2 3 4 6 by 5 4 7 8. How are you going to do it? Okay, multiplying these two numbers and dividing by this number gives an approximate answer, right? So can you give me the best approximate value without using calculator? No, right? So how are we going to write this is, we will first take logarithms on both sides. Okay, so log of x will be actually equals to log of 1 2 3 4 into 2 3 4 6 by 5 4 7 8. Okay, now using the above three properties which I have seen just right here, this is the first, the second, and this is the third. Okay, we won't be needing this one in this question, so we have to use only the first two. So whatever is multiplied gets added, whatever is divided gets subtracted. So we are going to expand this, so it will be equals to log 1 2 3 4 plus log 2 3 4 6 minus log 5 4 7 8, right? But logarithm values cannot be computed like this. Log values can be computed for scientific notations. Okay, so what is scientific notation? Like a number like 1.234, this is a scientific number. 12.34 is not a scientific number. Okay, this one is a scientific number. So we will convert all of these three. So how will we write? Equals to log 1.234 into 10 cube plus log 2.346 10 cube minus log 5.478 into 10 cube. Now again a into b. Okay, so we will be expanding it again. This is actually all these things can be done here, but I'm trying to show you how you can do in the middle of a calculation. Okay, so what will it be? Log 1.234 in the scientific form plus log 10 cube. Similarly, log 2.346 plus log 10 cube minus log, okay, let me put the bracket in right place. Okay, log 5.478 plus log 10 cube. Now see, a to the power b, if we are writing logarithm of a to the power b, then it will be b times log a, right? So here it will be log 1.234 plus 3 times log 10, right? And log 10 is actually 1. Okay? Log 10 is actually 1 to 3 plus log 2.346 plus again 3, got it, minus log 5.478 plus into minus gives us minus 3 log 10. So log 10 is only 1. So 1 3 and a 3 gets cancelled. So it is 3 plus log 1.234 plus log 2.346 minus log 5.478. Understood? Now this might seem that it's a long answer, right? But it's not. These numbers, if we calculate from log tables, which I will show you later on, if we calculate from log tables, then we will simply get a single 4-digit numbers. Okay? 4-digit numbers, 4-digit numbers, 4-digit numbers. That too in 0 point form, a decimal form. Okay? Then we can add all those with 3 and get the final answer. But that will be only logarithm value, okay, not the anti-log value. Anti-logarithm is going back from logarithm to the final answer. Okay? Now let's do a simple example. Suppose a question is given like a chemistry question type: x equals to 6.626 into 10 to the minus 34 into 3 into 10 to the 8 by 5428 10 to the minus 10. Suppose we have to compute this. So how are we going to write it? Take log both sides. Log 6.626 34 into 3 into 10 to the 8 divided by 5428 into 10 to the minus 10. Okay, now be sure to write all the scientific notations here only, not carry to the end of the equation. Okay, end of the calculation. So it will be this. See, this one is in scientific notation. This is also in scientific notation 3.0. This is not in scientific notation. So if we are going to put a point here, we have to multiply by divided 4. Sorry, divided 3, right? So the number turns out like this: 6.626 into 3 divided by 5.428 into 10 to the power minus 34 plus 8 plus 10 minus 3. This again reduces to 6.626 3 by 5.428 into our, how much will this be? This is going to be 7, 15, and 34 minus 15 is going to be 19 minus 19. Okay, so this is equals to log 6.626 plus log 3 minus log 5.428 plus log 21 minus 19. You don't need to write this step, just go to the next step directly. Log 6.626 plus log 3 minus log 5.428 minus 19. Understood? Okay. Again, take an example. Anti-logarithm will be in the next video. Okay, and then a third video will be there. Where we will be compiling the logarithm and anti-logarithm values. Okay. Third question. Suppose there is not third question. Let's try to compute with a logarithm table. Okay. So I will be showing the logarithm table here, and you will see the values. Okay. Now see how to compute log of 1.234. See, in the log table there are many rows, there are many columns, right? In the first column we will be searching the first two digit of our number. Okay, regardless of the point. Okay, we will not consider the point, but we will see this as a number. This has a decimal point in it, but we are not going to see that. Okay, we are going to overlook the decimal point. So 12, 3 and 4. So we will be finding 12. After you find 12 here somewhere, we will find the third digit here. So it will be 0, 1. Values will be like this: 2, 3, 4 and so on up to 9. Okay, so we are going to take the value of 12, 3 here. Okay, so what is the 12, 3 value? The 12, 3 value is 0899. So we will write as 0 point, then the number 0899. Okay, and then we will go to the mean difference column. See, there is a gap, and again this starts a mean difference column. Here we have to try find the fourth digit. Okay, so first two digits. So these are the two digits. These are the first two digits. These are the third, and this one mean difference column is the fourth digit. Okay, find the fourth digit and find the value. So the value here is 14. Now add that 14 here. So how much will it be? 0.0913. So logarithm value of this is 0.0913. Okay, now log of suppose 2.34. How much will it be? So first log 20. So first we have to find the number 23. So 23 and the third digit is 4. So 23, 4 is 3692. So 0.3692, and the fourth digit is 0. 0 is not in the mean difference column. It starts with 1, then 2. Okay, so there is no mean difference column. So the log value is 0.3692. Okay, suppose log of 0.245. How are we going to find this? This is not a scientific notation, so we'll convert it into scientific notation. So it will be log of 2.45 into 21 minus 1, right? It will be added, and then the power comes in front. So minus 1 plus log 2.45. Again the first two digits and the third digit. So the first two digits 24 comes at 24 5 3892. it is -1 plus 0.3892. So how much is it? 8016. Understood? Okay, so try to find logarithm values. Okay, now let's work this out in a simple case, like in this case. Okay, so what is the value of this? Log 6.626. It will be log 66 to 6. 66 2 is 8209, and the sixth one is 4, so it will be 8213. So 0.8213 plus log 3 is a memorized value. It should be 0.4771. Let me check it. Yeah, 0.4771. So it is 0.4771 minus log 5428. Log 5428 is 54, 2 and 8. 7346. 0.7346 minus 90. Okay, so write it out, add these two and subtract this one. Okay, so I'm going to write the answer. 7 plus 1, 3 plus 1, 4. So this is a number where the decimal is actually positive, and this means the non-decimal part is negative, right? This was the power of 10, you remember? So while doing anti-logarithms, this will be going to the power of 10. Now after logarithm, have you ever got any negative value? No, right? Means log of 6.626, is it negative? No, it should be positive. So how we will write this? We will write this as this. This one has to be positive, this is negative. So 19 bar point 056, sorry, 19 bar point 5638. This is the thing which we are going to find out in the anti-logarithm. Okay, so everything has to be like this. Suppose the number is, suppose let us take an example that a number comes like this, minus this one. This is negative, right? So minus 0.6108. The number came as minus 0.6138. Okay, so how are we going to convert this in the positive and negative form? Simply add a 1 and then subtract a 1. Okay, after adding 1, what we will get? We will get minus 1. Now this is a positive part, this is a negative part. Okay, so 1 bar point 3862, but the decimal is in positive part. Okay, try to work out some equations, some questions. Okay, wherever you have got this, you can continue in the anti-logarithm table.